As I was told on the tour at the beginning of this trip, when Swedes say 10:30, they mean 10:30. Hope everybody's had fun at the conference so far. I have had an absolute blast. I did not realize when I came here just how eclectic the mix of speakers and attendees would be. So I've been to sessions on game programming, .NET, agile coaching, microservices, and now we're talking about component decomposition. And I realized I hadn't really said that I wrote this talk in the context of web development, Angular, React, Vue, or any of similar technologies. But realistically, I recognize that there are component frameworks using any number of technologies, and that a lot of the things that we're going to talk about could apply to any of those as well. There we go. So to introduce myself, my name is Rob Ocel. I'm a senior software engineer at This.Labs. We're a primarily front-end, primarily JavaScript software consultancy, but we do other fun things too. I'm a host of a couple of our podcasts, like the Modern Web podcast and the This.Labs podcast. I do speaking on a lot of different topics, like something that we call the PAM stack, which we talked about yesterday, which is our tool for helping out juniors in software development. I like talking about frameworks, mentorship, and many other things. So if you're interested about any of those, feel free to talk to me after this. So to introduce the topic of what we're talking about today, how many of you have gone to fix a bug in your application or your single-page application, and you've opened up a component file looking for the bug, and you were shocked when you scrolled to the bottom and saw that the component was hundreds or maybe even thousands of lines long, and you wondered how you were ever going to figure out where it was broken? Or maybe you've started trying to track down the component that you were trying to fix, and you just keep opening up files like this, where there's no logic inside them, and the template just has one line in it, and it just points you to another component. And pretty soon you open up that component, and it doesn't have anything in it, and so you open up the next one, and pretty soon, your file list just starts to look like this, and you have no idea what you're trying to do anymore. Or, and I've had this a few times, you think you know where a certain value is changing related to the bug you're trying to fix, but you can't figure out why the piece of code never seems to get called. So you just add a lot of console statements, trying to figure out, why is this value changing even though this function doesn't seem to be changing? And you realize that it's actually changing somewhere else. And so you try to track it down where it is there, and then it changes somewhere else, and then you think you have it locked down, and then it pops up somewhere else, and you just really have no idea what's going on. So if you've encountered any of these problems, then you probably are dealing with some of the component design problems that we're going to be talking about today. But take a deep breath. I'm sorry I just traumatized you this early in the morning. We can fix this. There are solutions, ways to start to get on a path towards doing things better. But just to make sure we're all on the same page, because I don't want to assume that everybody here necessarily knows what we're talking about. You may be here just sort of interested about what components are. You might be getting introduced to this topic. Components are really powerful tools for building user interfaces and just software in general, right? So in general, when we're going to talk about them, we're talking about how components can encapsulate structure and style and behavior in some sort of reusable element, right? Some people like to say that they're like functions that map state or some initial state to some view. So we might pass in some sort of data into our little component box, and out will pop some view. Or we could pop in some different data into that same component and get a different view, right? Fundamentally, these are components. Why components are powerful is it doesn't just have to be that they produce web content, right? Sure, you could produce HTML, CSS, and JavaScript, but you could use a technology like React Native and spit out native elements for your phones instead, or any other type of approach. And you don't even have to just use JavaScript, right? You could use ComponentKit and Objective-C and build components in those in that way, or using any number of other technologies. That's why components are powerful, because they're architecturally similar even though what they do is different. So when we talk about decomposition, we could think about building our entire graphical interface, our entire program, as one massive component. Please don't do that. That's really scary, but you could do this. So we'd have to handle all this business logic and tons of DOM and view creation all in this gigantic file. But what we really want to do is find a way to break that large thing, our large application, up into smaller pieces. So component decomposition is that process of breaking up a large application into smaller and smaller components in a principled way rather than a random way, right? Again, this might sound obvious to some of you, but some of the things that we do actually sort of look like breaking things up in a random way than a principled way. We want to do things in an intentional way to achieve other architectural goals, performance or maintainability or all those things that we care about. So to show this in action, right? So we could look at Amazon, and we could say that this entire page is our app component, and then maybe this small piece at the top is the header, and the page that we're currently navigated on might be today's deals. And this small piece of that page is maybe just a carousel, and this piece at the bottom is the product grid, and that itself is broken up into smaller pieces like maybe a department list, and then each of these things might be a product entry. Is this what they do at Amazon? I don't know. I don't work there, and honestly, if I guessed right on my first try, that would be amazing. But this is just one of the ways that we could break this thing down into smaller pieces that might be concerned about one thing at a time. That didn't seem very hard, right? I just pointed at random things on the screen and said that they could be components. So why is this process hard? This process is hard because there is no one right way to do this. There's no mathematical formula. There's nothing that you can evaluate that says this is 98% correct and what you did is 87% correct. It's a bit of an art, it's a bit of a feel, and it's a little different depending on what your user interface is trying to do, as well as how your team works and how your team thinks. These are always hard things to do in development when there aren't right answers, because I've worked with lots of people and lots of teams where people just really want to be told, just give me the rules and I'll follow the rules. It's also hard because as developers, we're prone to premature optimization. We're smart people. We want to justify the salaries that we're given. So we always have a keen eye for where things might be similar. And we're very eager to assume that we're correct and that things can be abstracted at a very early time. This can be really difficult with components because if we're wrong, we pay badly down the road. So sometimes we have to fight these instincts that we've been trained in since we were students. And I like to call out object-oriented instincts here. So I was taught an object-oriented methodology, and many people here might be. And I think when we think in terms of object-oriented paradigms, we tend to think of larger pieces that form hierarchies and inheritance hierarchies. So we think of large things which are different from one another in small ways. And so when we take that kind of methodology and we apply it to user interfaces, we tend to think of large components which differ from other components in very small ways. Instead, if we had a functional mindset, people that have a more functional mindset are thinking about how to compose very small functions, combine them together in interesting ways to do more complicated wholes. It turns out that that methodology, that mindset, is a little bit more in line with what makes healthier applications. So sometimes if you come from that object-oriented mindset, some of the things that we're going to talk about will be counterintuitive, but very powerful when you learn them. So in the description for this course, I talked about the Goldilocks problem, and I turned out that this Goldilocks theory is actually really common in a lot of fields. So if you're not familiar with the Goldilocks story, honestly, I looked into it for this, and I couldn't believe it. I don't know what the point of the story is, but this girl stumbles across an abandoned house in the middle of the woods, and she decides to let herself in. And she sees 3 chairs at a table, one that's too tall, one that's too short, and one that's just right. So she sits in the just right chair and she looks at the table and there's 3 bowls of porridge, one that's too hot, one that's too cold, and one that's just right. So she helps herself to some food, gets a little tired, and she goes upstairs and sees 3 beds, one that's too hard, one that's too soft, and one that's just right, and she falls asleep. Later on, the bears come home and they find her, and they're a little confused why she robbed them and then slept in their bed. And so they scare her out of the house and she runs away, and that's the end of the story. Now, sometimes I feel like this problem exists on a lot of our projects as well. Now, minus the sort of sneaking into bears' houses and falling asleep in their beds. But people tend to break up their applications either too aggressively, and they make way too many components that are tightly coupled and sort of illogical, or they pull way back, and they don't have nearly enough components, and the components that they have are very large, with duplicate logic and very low cohesion. But some teams do things just right, and we're going to try to learn how to be like those teams. So let's talk about problem 1, the too many component problem. So this image comes from the React.js documentation, and I'll say first and foremost that the React documentation is actually really good, and this example is actually really good. But whenever I think of the problems that a lot of teams face with having too many components, I always think of this image, because what it shows is some sort of design that a designer's created, and some of the boxes are too light for you to see them on the screen here, but there's differently colored boxes sort of showing where they're going to make component boundaries. In this example, it makes sense. But if you interpret this incorrectly and apply this to a larger design, what it looks like you're doing is basically putting a box around everything, and then you're taking out like one or two elements and then drawing another box, and then taking one or two elements out and drawing another box, and taking one or two elements out and drawing another box. And it seems like you just keep doing this until you've run out of elements. And when you do this, you end up with a lot of empty components that don't have anything in them other than the next component. You have sort of this nesting doll of components going all the way down. And those components don't have a strong purpose. They don't have a lot of behavior. They don't have a lot of reason to exist. And you tend to have to navigate down them as you are looking for certain content. Now, this next one is something that I'm really guilty of a lot, which is people that run out, and when they get a new design spec, they immediately create all the components that they sound like they're going to need. So the common case of this is whenever you find out that your new design is going to have a list. I always immediately go, well, lists have items, so I know I'm going to need a list component, and I know I'm going to need a list item component. And then I go to implement them, and I say, oh, well, my list component just gets an array of items, so that's just going to be some UL, and then I'm going to map over those items, and I'm going to spit out list items. Perfect, right? Very generic, awesome. So then I go to my list item component, and it's just an LI with basically nothing in it. Now, why is this problematic? It's problematic because if I ever want to edit anything to do with this list, I'm probably going to have both files open at the same time. I kind of need both files to be open at the same time to understand how they're working. And realistically, combined, they're only like 10 lines of code anyways, so why did I have to make them separately? Well, I made them separately because I did it because, again, they have some sort of object-like decomposition, right? In my head, I said, oh, I have lists and I have items, so I'm just going to make separate things. But they didn't actually prove that they needed to be separate. And I've had a lot of applications that I've built where ultimately I really hated that I had done this to myself, and then ultimately went in and deleted the list items and put them into the list. I was really hoping this image was going to come out a little clearer on the big screen. But on this slide, what we're looking at here is a form, okay? And so this is just a normal form, and it's split up into 3 sections. And so a lot of people know that they need a form here. That's straightforward. But when they actually go to lay out the page, they go, wow, that's a lot, right? There's like 15 different fields here and 3 different sections, and my file's really big, and I've been told to have small files and small components, so I'm going to break this up. So they say, well, I've got 3 sections, right? There's personal information, account information, and contact information, so why don't I do that? I'll just make a personal information component, an account information component, and a contact information component, and I'm done. Now each of these files is very small, but what you realize is that you haven't really gained yourself any advantages from doing this, right? Sure, your large component is now small, but you end up actually having to have each of these files open to make any sense out of them, because they're all very related to one another. They're not actually reusable. You're not going to use this account information component anywhere else. It can only be used in this form, and only when it's placed between those other 2 components. So you might say to yourself, well, we would never do something like that. But I've seen a lot of teams that break things up this way, because again, it feels very natural. They just take this thing and they split it up into 3, but they haven't broken it up in a way that actually delivers some value. They've just hidden that length across 4 coupled files. Okay, so let's look at the too few problems. So if anybody was at our talk yesterday, I'm reusing this slide, but what I see a lot is something that I like to call the Bob Ross problem, which happens when developers get design specs and they immediately recreate everything in the design spec without thinking about where they might have pieces built already. So when you do this, you get lots of duplicate, recreated elements throughout your application. The same types of inputs, the same types of buttons, the same types of forms, a lot of duplicate CSS. And you end up with very large components that look like entire pages, because again, people are mapping one component to one design. The problem with this comes in down the road when you have changes to these designs, and you might change them in some components, but you might miss them in other components. Things get really fractured, and you pay a price. This is because large components mean large files. Large files are hard to read, to comprehend, and to search. And these large components end up with too many concerns. So they do a lot of different things. We'll talk about concerns more in a little bit later. And because of the fact that they do so many things and that those things are related to variables and some public methods and some private methods, you can get lost in the file and sometimes not realize what you have. And I know I've done this. I don't know if anybody else has done this. But you might realize when you get to a pull request or code review, somebody writes a comment that says, hey, that thing you built, it already exists. That method, that utility method, that thing you created, it's actually in the same file. And then you're like, oh, my bad. I didn't realize it existed. So another interesting case is when people try to implement a lot of similar components. So in this case, one example is card components in material design. So there are different types of cards in material design, and they all look very similar to one another, but they're different. And so some of them have things like descriptions, which seem the same, and some have images, and some have that, and some have these actions, but they could be text or buttons. And people aren't exactly sure in what ways they're similar. So they'll start out and they'll implement their simple card. Then they'll sit down to make their more complex card, and they're not sure which parts of the first card they can actually reuse. I kind of call this the one component trapped in another problem. Now, what they tend to end up doing is just copy-pasting everything from this card and then making it different here, and then copy-pasting it here again and making it different. And this might feel like this is more like the too much decomposition problem because I have 3 separate cards, but it turns out it's actually a case of too little, because what's missing here are actually the reusable components you would need to build these. So if you look at how different libraries like Material UI will implement these, they'll make these reusable components like card image, card description, card actions, and things like that, that they can then combine in meaningful and interesting ways to get these variant cards very simply. Now, sometimes people try to be too clever and reduce the number of components that they have by forcing reuse where there isn't reuse. This can happen when there are 2 components that are very similar, but just ever so slightly different. So what will happen is people will tend to make one component and have it do 2 different things, usually toggleable with some sort of property. These kind of components are called multimodal. They have 2 different modes or multiple different modes that they occupy, and in each of those different modes, they'll behave or render very differently. Now, as I was preparing for this talk and trying to come up with an example of this, I watched this talk by Jen Creighton at ReactConf called React is Fiction, and wouldn't you know it, but she came up with the exact perfect example I was looking for, and I realized I couldn't possibly come up with a better one without being inspired by this, so I decided to show that. But after this talk, when you go home, I want everybody to go watch her talk, React is Fiction, and then go on Twitter and tell her that she did an amazing job, because this talk is really, really good. But in her example, she's describing how to implement this sort of navigation bar. And this navigation bar has a logo, some links, and then some call to action to the right, which is different if you're logged in or not, right? So if you're not logged in, you get this login and sign up. If you're logged in, you get sort of this access to your profile. Pretty good, pretty straightforward. A lot of our apps probably have similar things. So her pseudocode implementation, her first draft of a solution for this looks something like this. So you have a navigation component with an isLoggedIn property. You show the logo, you show the links, and then if you're logged in, you're going to show the avatar, and if you're not logged in, you're going to show the login and sign up links, right? And so a lot of you here are saying, what's wrong with that, right? Nothing seems to be wrong with that. I have a lot of components that look just like that. That's completely reasonable. And the problem actually comes in when you might start to get more complicated requirements going forward, right? So what if now, when a user's logged in, we want to do some different stuff in the top, whether they're an administrator or just simply a user? Well, now we have 2 Boolean properties that we're passing in, and we're handling those in all sorts of different places, potentially in our markup. And it can get really easy to get confused or to make a mistake. Or you come in to implement something that ultimately should only be shown for users, and you forget to set the right privileges on that section, and it actually affects the different views for the admins and for the members or the logged out users, and things start to break apart. In its most severe case, you might continue to do refactorings in that way until you have this problem where you just sort of say, if is logged in, all this HTML, else all this HTML. And that's when the problem has become the most obvious, right? That you have actually two components that you've prematurely jammed together to be one component because they looked similar. So you have to be really careful when you're making components to decide, when I'm combining things, am I combining them because they're intentionally the same, or am I combining them because they're incidentally the same? They're just a coincidence that they look similar now, but they don't have to be in the future. OK, so if that's the too much and the too few, then what might just right look like in the future? So just right on a project might be that the component's purpose, all of our components' purposes are clearly and concisely described. It's easy at a glance to know what they're trying to do and what they're actually responsible for. We'll have a lot of components that are basic reusable atoms that can be composed together. Of course, we'll have more complicated components, but we'll be focusing on the things which can be used to more rapidly build those complex components from simpler pieces. We'll have no need to look at the implementation of other components when we're inside of one component. This is because the components will have clearly isolated concerns, so that you can know that as long as the component does what it says it does, I don't have to go look at how it does it. I can trust it. We'll see how powerful that is. Data will be fetched and mutated in minimal locations. This is, again, a separation of concerns, and we'll talk about how this is also an isolation of complexity, and how this lets us have simpler components and also more predictable UIs. And we'd use as many peer components as possible. We won't talk much about peer components here, but peer components are ones that will always produce the same view when given the same inputs. They don't have side effects, they don't have internal state and things like that. The more of these that we have, the more predictable our user interfaces will be. But we can't do everything with them. But we'd still have more than in systems that aren't doing things right. So let's talk about some strategies for actually doing this. The first strategy is with routable components. So what we want to do here is put content that is swapped together into a single component. This is because it's a lot simpler to swap out one component, which groups some things, than to swap out many individual pieces of content together at the same time in the same way, right? It's more error-prone to have to do multiple operations instead of just one. Now, this is, coincidentally, how most routers work in single-page application frameworks. You define some sort of route, and then you tell it a component that you want to mount in a particular place in your user interface. So because of this, this advice seems obvious, but still some teams don't do this, so it's worth repeating. I've seen teams use routes where they actually pass the same component to multiple routes, and they just have the route pass in a parameter, or the component itself looks to the route to decide how it should render itself a little bit differently depending on which route you're on. But this advice doesn't just have to apply to routes. This can apply to wizards and tabs, which is kind of an underutilized place for this type of an approach. But you have to be really careful when you do it, because we don't want to end up like our form from earlier where we just group content pointlessly. We want to make sure that the content is independent and that the content swaps out together. So an example of this, again, getting a little washed out on the screen, but it's a wizard here, a 3-step wizard with various different steps. And what we're doing here is that each one of these steps in the wizard is independent. So we could implement this as one large component, which with each of the sections just simply conditionally hidden or shown depending on where we are in the wizard process, right? This is totally doable. Or, because each of the steps is independent, we can make each one of the steps its own component and then have a parent component that manages the wizard itself and then mounts each smaller component into place when it's on the appropriate step. And when you finish each step, that messages up to that parent component, and it'll swap in the next one. So again, this can be really powerful because each one of these steps is independent, and it doesn't need to know that it's part of a larger flow, so that you could theoretically edit each one of these separately and change the flow without having to change these components, which can be really powerful. So the second strategy is to look for reusable components, right? So we want to create small components that, when combined together, are going to build complex components more easily. But while we do this, we want to be really careful to avoid making these multimodal or overly similar components, right? Because those types of components aren't actually truly reusable in the sense that we mean them. They just reuse the same code file. They're used separately and uniquely, configured in the way that they need to be where they're used, but they're not truly reusable in the way that we're thinking about it. Plus, reuse is a lot more potent as components get smaller and less complicated because they're applied or they're applicable to more varied use cases, right? The more specific, the more focused or the more complex a component is, the more difficult it is to reuse it because you don't always need all that complexity. And the best example of this is that design systems, of course, are great sources of reusable components. It's why design systems, I think, are so big nowadays in development, is that they really define what are the building blocks or the reusable components of your system. So let's go back to that form example from earlier. Remember, we broke this down into sort of 3 groupings of fields before. But how could we break this up a little bit better? So a better way to break this up might be to just simply break it up into the individual atoms of the design. Now again, some of this seems obvious, but you'd be surprised if you look in your own applications and other people's applications how infrequently this happens. So rather than repeat the same HTML and the same CSS over and over and over again, creating that large file, we'll break it up into reusable cards, typography elements, inputs, and so on and so forth from our design system. Again, these would encapsulate HTML, CSS, and maybe even some JavaScript to control things like accessibility or maybe some performance elements. And then we can put these together very, very quickly. You can prototype this form very quickly with relatively few lines of code by reusing these components. So wheresoever possible, when you have a large component and you're trying to figure out how can we break it up, don't always think about how you can break it up sort of structurally. Think about how there are elements of that page which you're duplicating many times that if you isolated those would let you rebuild the page much more fast, much more quickly. So the next example is going to be specific components. So I would argue that we should prefer specific components over generic components. And when I talk about specific components, I'm talking about components where we're not trying to do any form of abstraction. They are what they claim to be. They are what we see. And here I like to say that we should follow the rule of 3, right? So the rule of 3 says that obviously the first time you build something, you just build it. But then if you build something very similar to it, the first time, just copy it. Don't worry about trying to find the ways that they're the same or abstract something between them. Just copy it. The first time you duplicate, just duplicate it. But the third time, and so on and so forth, then you can start to figure out, I've used this same exact set of HTML or the same pattern 3 times now. Are there certain patterns that have now emerged through the 3 uses that I can abstract? If there are, pull them apart at that level, at that time. This reduces the amount of times, again, as I said earlier, that content is sort of incidentally the same, accidentally similar. If you're reusing the same pattern 3, 4, 5 times, then this is going to be content that has proven it's the same in many places of your application, and it's probably safe to abstract at that point. Sandy Metz said that to prefer duplication over the wrong abstraction, and Ken C. Dodds likes to call this aha programming. So he contrasts it with dry programming, which is don't repeat yourself. It's something that a lot of us have been taught, right? To never write the same thing twice. He likes to call it aha programming, which is avoiding hasty abstractions. This idea that it's a worse crime to abstract early than it is to copy-paste the same piece of code in multiple places. So let's go back to our example from Jen Creighton's talk. So again, we're making these navigation bars. And she has sort of a naive first implementation. I'm not calling her implementation naive. She calls it naive. It's the first implementation in her talk, where she splits it up into these reusable nav sections. Because in the logged out navigation, remember here we had kind of those navigational links to go to different parts of the app. And then over on the right-hand side, we had the links for login and sign up. So she said, oh, well, I have groups of links. That's an abstract component. So I have this reusable nav. Now, again, this can get in trouble. This doesn't have to get you in trouble. If you always represent your links in the same way, that's fine. This might be great. But as soon as these start to be a little bit different, you need icons, or maybe you need a search box in some conditions, you need things that are different than links, suddenly this data that drives this component needs to get a lot more complicated to account for all that variability. And then the implementation of this component also gets complicated to introduce a lot of that variability. And believe it or not, we've now recreated that multimodal component, which again is many different components masquerading as one component that needs to be split apart. So what do we do instead? Let's just be specific. Let's break it apart. And even though both of our implementations of our navigation might have many of these links in them, that doesn't necessarily mean that we have to abstract them. It's totally fine to make a component that's like this. Again, because if we want to decide that suddenly this happenings link needs to have an icon, we just put an icon where it needs to be. And we don't have to worry about how does our data model need to change and how do we need to change our components to represent that generically, right? We just add the icon. And if we want to represent something as an anchor tag instead, then a link component, we can do that. If we want to add input boxes, we can do that. And again, when we do this, if we suddenly decide that we're doing a lot of links and icons, multiple different places, well, then maybe we combine that together to make some sort of new reusable component so that we don't have to do this over and over again. But again, let's let our abstractions prove that they need to exist. Make them repeat themselves. Show you that they actually do repeat in your application, and then extract them. Because we want to extract those things to save ourselves time, but we don't want to do it for no reason. So the next strategy is isolating concerns. So concerns are a tough thing sometimes to get your head around, but for all intents and purposes, they're just sort of like independent things that we have to worry about, right? So, you might have to fetch data and save it, or if you're in a to-do app, you have to actually check to-dos off versus adding and removing them from the list, right? These can be different sets of concerns. So ideally, we can isolate these concerns by putting them inside of components that deal only with that concern. That concern is solved in only one place, and that place only solves that one concern. The more that we can get a one-to-one mapping between components and concerns, the better off we'll be. The goal of this, or the advantage of this, is that components get smaller. And another advantage is that you don't have to open up many different component files to understand one component that you're looking at. For isolating these concerns and you need to solve a problem related to that concern, you open up the one file. If you're looking at a component that uses it, well, because it doesn't need to worry about that concern, that's why you isolated it into that other component, you don't have to open up that second component, you just trust that it's working correctly. This makes our components more cohesive and less coupled. So the best example I can think of this is the downshift library by PayPal. So the downshift library in React helps you build autocomplete boxes. Now, autocomplete boxes, because they don't exist in native HTML yet, can be really difficult, especially difficult when you have to deal with input controls and accessibility. So there's a lot of concerns, right? The behavior of these things can be tricky. Accessibility is difficult. The input control is also hard. And of course, how to actually display it in a way that is meaningful and fits your theme for your application. The downshift library helps us isolate that by taking away all of the behavior and the accessibility and input control concerns and letting us focus on the styling. So everything to do with the behavior of an autocomplete is contained entirely inside this component. And using the render props pattern, I think now they might use hooks, but using the render props pattern here, they pass us these sort of variables. Then we get complete control over the rendering of the autocomplete box. And as long as we use those variables, those properties that we were given in the right places, all that behavior, all that accessibility, we get all of it for free without having to worry about it, right? We've isolated that concern. Now we just focus entirely on styling, and we let it handle all of the complicated bits. So our autocomplete component is very simple. It's very straightforward. And we have a lot of trust that their component is helping us out. Now the last strategy is about using complexity boundaries or crossing complexity boundaries. And this one can be a little bit difficult to grasp at first, but it can be really powerful when you actually notice it in your applications. So first, let's recognize that components don't have to know everything about your application to provide value. This is obvious if you think about input boxes. These are these basic HTML components for taking input. Those input boxes don't need to know whether they're holding an address or a username or a search query. They just know how to accept user input and event out certain things that happen. So similarly, these types of approaches, can reduce complexity by leaving context in a parent component, right? This will simplify design, implementation, and testing. It can make our child component easier to reason about. Again, like an input. It's a lot easier to think of an input than to necessarily think of a password input. And an interesting side note, if I do a little bit of a digression here, is when I was writing this, I was thinking, this is weirdly true of companies too. When executives get together and they're thinking of things, they have a lot of additional context, right? But when they pass that down to middle managers or to workers, they have to remove some of that context because that context isn't meaningful at the lower levels, right? If you're a developer, you don't necessarily need to know about next quarter's profitability stats, right? Like that's not necessarily relevant to you building the software that you're building. So as information and directives flow through your company, it's stripping away context and giving you only the information that you need to get your work done. Then as you get your work done, the results of that work bubble back up through the organization. That context is layered back in. Additional interpretations are made. That data flows back up. That's sort of a healthy company, healthy corporate hierarchy. And interestingly, it makes for healthy projects and software as well. So here's a simple example of a color status indicator. We'll give it a value and 2 thresholds. And depending on the value and the thresholds, it's going to render a red, yellow, or green outlined circle. So why is this interesting, right? Why is this component worth talking about? Well, it's interesting because we don't know what this value is. We don't know whether this value is the temperature of a reactor core or whether it's some value on a budgeting spreadsheet. We don't need to know. Similarly, we don't know what these thresholds mean or where they came from, right? We don't know whether it means that the reactor core is about to melt down, and we don't have to know, right? We just have to know how to interpret this value relative to these thresholds in a meaningful way to produce some value to our application. And then it's important for the parent to then incorporate that, add the additional context, oh my goodness, right? We're about to melt down, and then do something interesting with that information. Again, it makes this component very simple and reusable because it has a very generic purpose. It may not, again, be immediately obvious where this is going to be relevant in your applications, but if any of you use Redux or any other global state management, I'm betting you're going to find examples of this. Because what happens is the power of Redux and MobX and all these other types of global state handlers, which I love, by the way, I'm not arguing against them, is that you always have access to that store, which means you always have the ability to make components a lot smarter than you want them to be. They can pull additional context out of the store, get data out of the store, and with that data comes the context of what that data means. I've seen a lot of teams struggle having overly complicated components because they reached into something more global than they needed to be and made a component way smarter than it needed to be. It's harder to test, it's harder to reason about, and again, it mingles concerns, and it causes that problem with the cat having trouble figuring out where the values are changing. So in conclusion, there is no definitive way to know if you did things right? I don't have a magic answer for this. I'm learning more all the time. This is a process. This is a journey more so than a set of prescriptive things that you for sure can do. So along those lines, as your team is learning, make sure to make this a group exercise. Get together when you get a new design or you're designing a new feature and really discuss amongst yourselves how you want to break that up into different components. Have your arguments and your conversations at that point. That means that you have to make time in your process to actually produce software designs, right? A lot of us aren't doing that on our teams nowadays, and it's really a shame. But you really want to have these kinds of conversations before implementation. If you wait until the code review stage, what's going to happen is you're pretty much committed at that point to the current implementation. Because like I said, there's no definitive right way to do things. So what they have is probably good enough. And as a team, you're going to say, we'll live with it. Right? It's not worth going back at the time of code review and make a lot of significant changes to the way that you've broken up your components. So you really want to do this before implementation and have software designs and design reviews. Then, whenever you have time, after you've delivered some code, look back and say, wow, we've been working with these components for a couple months now or a couple releases now. What do we think? Have we had any particular problems? Are there any of these components that we really despise opening up now? Are there any things we wish we had or any other patterns that we wish we would have done in retrospect? Have those conversations. It's going to make all your future work better. And of course, when in doubt, as I've sort of mentioned, if you just want a couple of takeaways, prefer duplication over abstraction and prefer composition over inheritance, small pieces that build to a greater whole rather than large pieces which differ slightly based on some configuration variables. And if you want a review of the decomposition strategies, so we're looking for components which are routable, or components that are reusable and composable, components that are specific, components that are concern isolating, or components which bound complexity or cross complexity boundaries, right? These are some of our objectives for building components that ultimately do more for us and don't give us a lot of headaches. So that's it for me. I hope everybody learned at least one interesting thing, and if you have any questions, I'm happy to entertain them up here. Thanks, everybody.